So today we will be solving LeetCode question number 589, and that is N-ary tree pre-order traversal. So we have to do a basic thing, that is just a pre-order traversal of the tree given to us. What is a pre-order traversal? Like for example, we are given with this tree. So root left and right, root left and right, root left and right. And hear me out when I say root left and right, till the left exists, till the right exists, and root. Okay, root left exists, right exists. Okay, so root left exists, so that's why we had 1, that is the root, the first most root. 3 left exists, yeah. 5 left exists, after 5 no. Then what? Right. Okay, right. Now right exists, now left, now it's left exists, no. You return it back, you went, then again you got 2, 3 we had already added. So now root root left exists, yeah, finished. Right, okay, again left exists, no. Right exists, no. Return, return. More, anything more exists, no. Then whole return. Anything more, no. Return, return, return. Then again u3 also return. Okay, 1 went ahead to 2. Okay, 2, does its left exist? No. Does its node has any children in left side? No. And right side? No. Then I think it's the time for root. So we appended 2. Nice. So far so good. Then 1 went to 4. Okay. Does its left exist? No. Its right exists? No. Then before going there only, we have already added 4 because it says root left and right. So whenever we are at any root, we will first be adding that root, then we will be checking its left. Left will be again treated as a root. So then that roots left and right. Again, if there is something in the left, there is something in the right, we will go ahead and then call for that, taking that left as a root and then going towards that left roots, left side and right side, and that goes on and on and on. But in this question, it's an N-ary tree pre-order traversal. So if we are given a root, okay, then its children are all the means it is not specifically a binary tree, because it's an N-ary tree. It's not a binary tree. So we can have more than 2 children for a single root node. Okay, so we need to do a pre-order traversal of an N-ary tree. Okay, so far so good. What was the case in a binary tree? Root left and right. Same will be the case in an N-ary tree, in an N-ary pre-order traversal. So what we will be doing? Root left. Okay, left exists, yes, or I should say children's exists, yes. Go on to the children's. Does the children's exist? No. Append this children. Okay, return it back. Any more children exist? Yes. Go. Does children exist for this node? Check. No. Append and return back. Time is finished. My children are finished. I return back. I trace back. 1. Any more children exist? Yeah. 2. Append it. Okay. Append it. Your children exist? No. Return back. 1. Any more children exist? Yes. Append it. Any more children exist for 4? No. Return it back. So that will be the case. That will be how we will be going. I think the logic is clear in your mind. I think I should now code it. So how will we code it? We want to return a pre-order. We want to return the pre-order traversal in a vector form. So I think I will at starting I will be creating a vector int res resultant vector that will be storing all the um, nodes value. Okay. Now yeah, I think I should call the solver, or I think yeah, solver, I should call it solver function. And I'll be passing in my root, I'll be passing in the res. Okay, and at the very last I'll be returning my res, and that is it, good to go. I think we should just start with the void solver function. what the solver function gets is the root node, and then a vector of int ampersand resultant. So far so good. If at any moment I know that, as I was saying, does 5 has any child? No. Then that means this is a null case. Our root is now null. After this, if I would be going to left node, that would be a null node. So whenever you encounter a null, if root is equals to null, then what is your duty? You just return. Okay. Now, as I said, I'll be iterating over each and every node's children, each and every node's children, each and every node's children. So for auto nodes in root root children. Okay, so we access the root children by this way. Okay, for auto nodes in root children, what I will be doing, I will be saying that if you are now at this nodes root children, you just need to call the solver function. Okay, and please do uh, take this new node as the root and call for res. And I think before doing this, if I just add um, resultant dot push back the root value, I think that is it, good to go. If I just try running it, that should probably, okay, that is a wrong, uh, but yeah, that would not be here. Sorry, my bad. That will be down here. And if I just submit this, wrong answer. Okay. Solver nodes and res dot push back this, and if this is a root is, if what is the output, 3 for auto nodes in root children. Solver gets nodes and whenever I am out of this, I think no, something is going wrong. Whenever you are iterating over each and every children, what you need to do, you just need to call, if root is null, return, else for auto nodes in root children, I'll be calling solver, and I'll be doing res dot push back the value, the node's value, I think, node. Yeah, that is it. Sorry, nodes. Sorry, and that is it. That is it. My bad. I was doing wrong, but I think I'm still doing wrong. 5, 6, 3, 2, 4. Okay. For root in children, I'm going to each and every children, and like if I am at 3, I just did nodes dot I just called it back. I think this should not be the case. This should be after this. Firstly, we should be adding. Okay. 3, if I went to 3, I should be adding 3 first. So it is 3, 5, 6 to 4. Yeah. And the thing that is left to us is now, appending the 1, appending the first node as it is not being added. You can see, as you can see, we are having 3, 5, 6 to 4. And the 1 is missing. So if I just go on and before calling my function, if I just append the starting roots value, then res dot push back the root value, and that will be the first node's value, then I think that is good to go. That is accepted. But before letting the video off, I will be explaining what I did. I firstly called the function. I firstly appended the roots value, whatever might be on the top. Then I went on to solver function. I passed in my root, and then I said that hey root, I think I should iterate over your one's children. Now I am iterating over one's children, and as and when I iterate your children, I will be appending them in my resultant array. So I went on. I said 1. What's your first children? I said 3. He said 3. Okay. Now I am at your first children. Now I think I should iterate over your first children's. Okay. It went ahead. Solver function. Your first children's. So 3 said my first children. 1 said my first children's. Okay. My grandchild. It is his children. So 5 is 1's grandchild. So 5 said now I will be appending. So now 5 I appended. It said 3, 5, do you have any children? He said no, I don't have any children. So you just return back. 3, you have any more children? Yeah, I have any more children. So it said who is your children? Next children? It said 6. So it appended 6. Like in when it returned back. Then once it asked 1, are you left with any more children? Yeah, I am left with any more children. So it is 1, it is 2. So res.pushback nodes value, it is now at 2. Do you have any more children too? No, sorry, return back. Then it went to 4. Do you have any more children? No. But before knowing his children, I'll be appending this child, okay? So I think the logic is clear. The discussion is clear. We had a very deep discussion on it. And if you have any doubts, oh, I have not submitted it till now. Sorry, my bad. Let us just try submitting it. Okay, edge cases are left. If I just say if root is null at the starting only, if root is null, you may please return an empty array. And that is it, good to go. If I just submit this, that would be accepted. Yeah, that is accepted. And yes, that is it for the video. And if you have any doubts, please do comment it down in the comment section. We'll be meeting in the next video. Till then, take care and bye.
Hold me close till I get up. Time is barely on